In the previous lecture, we have dealt with different aspects of motion of bodies with uniform velocity and uniform acceleration. But how a body at rest becomes a moving body, or how acceleration is produced in a body moving with the uniform velocity, has not been discussed. Famous scientist Sir Isaac Newton gave us these three laws of motion. These laws are known as Newton's laws of motion. Newton's Newton's laws of motion. Newton's laws of motion. These laws are considered as the pillars of the kinetics. So this is the pillars of the of the of the kinetics. In this chapter, we will describe and explain those laws and discuss the relation between velocity and mass with the motion of a body. So first of all, we will discuss a topic or a point which is known as inertia. So what is inertia? The definition of inertia is it is the property of a material object to preserve its own state of rest or motion. That means it the this is the property when a body will be preserve its state. Like suppose we take an example, a bus. This is the bus which is not moving, it is in rest. When it starts moving, then what happens? Our lower part of the body is moving with the bus, but our upper part are still at rest, where our lower part is moving with the bus because our lower part is connected with bus. So in that case, we will go backwards, or we will lean backward when the bus start moving from rest to motion. This is the case of inertia. Our body tries to preserve its rest state. That's why as our upper part stays in our rest state, so we lean backward. Now another example, when the moving bus press brake, what happened? Our upper part moving, but our lower part of the body are at rest because we press the brake, so it stopped. So what happened? We will go forward. Our upper body will go forward because of our upper part is moving. So this is the property when in that case it preserves its state of motion. So this is known as inertia. Inertia plays an important role in these laws of motion, and this is known as when our body is trying to be at rest. This is known as inertia of rest. And when our body is trying to, or when some body or particles trying to be in moving position, this is known as inertia of motion. Now coming to the second point, which is known as force. So what is force? The definition of force is any influence capable of producing a change of state, of rest, or of motion of an object. Or we can say that a force is that which changes or tends to change the state of body. So which changes or tends to change the state of the body. So what that mean? Let us take an example. Suppose a book is on the table. A book is on the table. In order to move the book on the table, something is to be applied on that book. So if I want to move this book from this place to this place, something needs to be applied on that move. Otherwise, it will not move, it will remain same. So this something which we apply to change the state of this body, is known as force. So this is the force when we apply something which tries to change or tends to change the state of the body. This is known as force. Now coming to the next point, there are some fundamental forces. These four are the fundamental forces. These forces are known as gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. So what is gravitational force? In the universe, there exists an attraction force between any two particles or objects. So if it is an object A and if it is an object A2, this is A1 and this is A2. So there is an attraction between these two objects, and this attraction is known as gravitational force. And it states that if the mass of this particle A1 is m1 and the mass of this particle A2 is m2 and the distance between these two is suppose d, so gravitational force states that the magnitude of this force, so suppose the gravitational force is f of g, the magnitude of this f of g is equal to product of mass, not equal to, the magnitude of the gravitational force f of g is proportional to the product of the mass. So product of the mass is m1 is m2 and it is proportional to the magnitude of this force and inversely proportional to the square of the distance. So inversely proportional to the square of this distance. When we want to change this proportional sign, we will add a constant, and this constant is known as gravitational force G. D square. This is square, not D2. This is square. So this is the formula for our gravitational force. Now coming to the next fundamental force, which is electromagnetic force. So first of all, let us take an example of two magnets. The force between two charges is called electric force, and that is between two magnets is called magnetic force. So if I take two magnets M1 and M2, the attraction or the repulsion between these two magnets is known as magnetic force, and attraction and repulsion between two charges like Q1 and Q2, two charges, is known as electric force. But electric force and magnetic force are closely related to each other. The electromagnetic force is the combination of electric force and magnetic force. So electromagnetic force are the combination of these two forces, magnetic force and electric force. When charged particles are in motion, they create magnetic field. On the other hand, varying magnetic field acts as the source of electric field. So that means when there is a magnetic field, automatically there a small quantity or big quantity electric fields is created, and on the same time, if there is a electric field, we can find a magnetic field, a small or a large magnetic field on that electric field. So this is known as electromagnetic force. Now the third one is strong nuclear force. So what is strong nuclear force? Strong nuclear force is the force that binds nucleons on the nucleus together. So we know in nucleus there are two particles. One is proton and the other one is neutron. And neutrons are chargeless, but proton is positive charge. And when there are too many protons in the nucleus, so this positive charge will repulse to each other. But there are some force that binds these protons to not uh, to not break this nucleus, and this force is known as strong nuclear force. So now coming to the next part, coming to the next fundamental force, which is weak nuclear force. So what is weak nuclear force? In nature, there are some elements whose nucleus disintegrate spontaneously. Like in uranium, if the uranium is disintegrate spontaneously, there are some rays are disintegrate from this uranium spontaneously. There three types of rays or particles are emitted from this radioactive nucleus. Like this is known as uh, alpha particle or beta particle or gamma ray. So these three rays or particles are emitted from our radioactive nucleus. Weak nuclear force is responsible for the emission of beta particles and neutrons. So weak nucleus are the responsible of emission of beta particle. When beta particle is emitted from nucleus, there is a force is applied to remove this beta particle or emission of this beta particle, and this force is known as weak nuclear force. This is the four fundamental force we have discussed. Now coming to the next and the last topic of this video, this is known as momentum. So what is momentum? The product of mass and velocity. The product of mass and velocity is called momentum. So suppose a bus is moving, and the mass of this bus with passengers is capital M, and the bus is moving with velocity v. So the momentum p equals to m into v, and also momentum is also a vector quantity. So when we multiply mass with the velocity, we found the momentum. We found the momentum. We'll discuss this momentum in our further lecture, and this momentum is a very important thing in this laws of motion. That's all for today's video. In our next lecture, we'll discuss Newton's laws of motion. Please like this video and subscribe to our channel. Thank you.